All right, so we're going to use completing the square to write the quadratic in vertex form. So that means that the first thing we're going to do is we're going to factor out a 5 from the x terms because we can't have a leading coefficient of 5. We need a leading coefficient of 1 there. So we're going to factor out the 5, and that gives us 5 times x squared minus 5. And so from here we can complete the square because we have a leading coefficient of 1 there. So to complete the square we need to take half of 5 and raise it to the power 2. So that means we're going to take half of negative 5 actually and raise it to the power 2, and we're going to add that number in this spot here. So we're going to add in a 25 over 4. Add in 25 over 4. So we need to keep the equation balanced, and I've changed the balance of the equation, so that means that I need to either add in the same amount to the other side or subtract that amount on the same side to keep it balanced, right? So I'm not really adding in only 25 over 4. I'm adding in 25 over 4 times 5. So I need to subtract 5 times 25 over 4, which means we're going to subtract 125 over 4, because 5 times 25 is 125. You guys good there? Yep. So from here we have a perfect square trinomial, and that's going to give us, we have x minus 5 over 2 to the power 2. You guys with me there? Sure. Yep. Yeah. Sure is not a definitive answer.
Sure.
Definitely yes.
Okay. All right, so I also need to get a common denominator here, right? So I'm going to multiply this one by 4 over 4. And so that's going to give me a 48 over 4 minus 125 over 4. And so that gives us g of x is equal to 5 times x minus 5 over 2 power 2. And then we have 48 minus 125 is 77. That's over 4. So that's our vertex form. Okay?
Sure. Yes.
We good?
I suppose.
Well, it's an honors pre-calculus student. You should know how to add and subtract fractions, right?
Definitely.
You're getting credit
draw?
Okay. So this next one here, I'm on a 15-minute budget, so we got to hurry up and get through this. We have to write an equation for a quadratic function whose graph contains the vertex and point. So we want to write a function in vertex form, where we have vertex form as a times x minus h squared plus k. Now, you guys, we have hk here, and we have a point xy. The only thing that we don't have for the vertex form for the equation is the a value. So we need to figure out what the a value is equal to. So we need to plug in the point xy along with the hk in order to figure out what the a value is equal to. So let's plug in hk to start. We'll plug in the 1 there. We're going to have a plus 1. Remember, we do the opposite there. And then the k value we have is 5. Don't forget that's squared there. And our y value is negative 13, and our x value is 2. We're trying to solve for a right now. And so first thing I'll do is I'll subtract 5 to both sides, and that gives me a negative 18 equals a times 3 power 2, which is 9. And so if we divide both sides by 9, we end up with a equals -2. And so we have y equals -2 times x plus 1 squared plus 5. And that there is our vertex form. Just want to give these cross-country guys some excitement, you know. Say hi, Jenny.
Hi.
All right, let's move on to the next one. So this one here, we want to rewrite the equation for vertex form, in vertex form, and use the fact that h is equal to -b divided by 2a. We have, remember, vertex form is when we have a and h and k, right? And so we actually have a already. We have a because the a is right in front of the x squared. The b is in front of the x. The c is at 6 there. We're going to find out the h value. So we're going to plug in b. So we have a minus in front of -2 divided by 2 times a, which is 4. And that gives us h is equal to 1/4. So we have the h value of the vertex, or we have the x value of the vertex. If we have the x value of the vertex, how do we find the y value of the vertex? If you have the x value, you plug in the x to find the y, right? So I'm going to plug in 1/4 here. So I have 1/4 going in the x spot, because that's the x value of the vertex, and so I want to find the y value of the vertex. Okay, so we have 4 times 1/16, and then we have a -2, 4, -2/4, and then plus 6. So if I reduce, we have 4 times 1/16, that's 1/4, minus 2/4. And I need a common denominator, so I'm going to multiply the 6 by 4/4, which gives us a 24/4. That's just a fancy 6. And a 1 minus 2 is a -1. -1 plus 24 is 23, which gives us the k value, right? So our vertex form then is f of x equals a, which is 4, times x minus 1/4 squared plus 23/4. Are we good there?
Definitely.
Yeah? It's not that hard, is it? Yeah. Okay, next one. Okay, so this one here, most of you guys were actually pretty decent on this one. Use the limits to find the end behavior of the function. Remember that we find end behavior by looking at the leading term. And because my leading coefficient is positive, I know that as x increases to positive infinity, my y value will increase to positive infinity. And remember that because we have an odd degree, we have the split ending behavior. So as x goes to negative infinity, the y value is going to go to negative infinity. Remember, you guys, that you would actually see that if you were to plug in the x values here, right? If you were to plug in the x values, you would actually see this pattern. So from here, we're going to look at this one here. That tells me the leading coefficient that's negative tells me that as x increases to positive infinity, the y value will go to negative infinity. And because our leading coefficient has an even degree, we have the same ending behavior. So as x increases to negative infinity, the y value is going to go to negative infinity. Alrighty? So far so good? Okay, so the last one here, we want to sketch by hand. And so the first thing we need to find are the zeros. And we take the opposites here, right? We have a 2 as a 0. What x value could you plug into here to make a 0? 2. Right? We have a negative 1 that's a 0. Negative 1 plus 1 would give us a 0 for that factor, right? What x value could you plug in here to give us a 0? 3. 3 minus 3 is 0. So we have 3 for a 0 right here. We have an even multiplicity here, which tells us we're going to bounce off the x-axis at positive 2. We have an odd multiplicity here, which means we're going to go right through negative 1. We have an odd multiplicity here, which means we're going to go right through at positive 3. If we were to expand this entire thing and multiply everything out, we would end up with a leading coefficient that's negative. The actual leading term would have a degree of 4, right?
Yes.
So we know that as x increases, the y value is going to decrease. The power of 4 tells us that we're going to have the same ending behavior, right? We know that at 2 we bounce, right? So we're going to bounce off this guy. We're going to go through this guy. We're going to bounce off this one. And we're going to come back and go through that one right there, right? You guys, I wasn't testing to see how high you were going to go or anything like that. I was just checking the overall structure of your graph. Another thing that you guys could do if you were not certain about your graph, it's not magic. You can actually plug in x values to see what your graph is doing, right? If you plug in x is equal to 0, you have negative 2 power 2, which is 4 times 1 times 3, which gives you a 12, right? So when x is 0, y is 12. You know that you're going to have a point up there, right? And also, you could plug in 2.5 in between 2 and 3 and see that your graph should be in the positive here. You could plug in anything after 3 and see that your graph should be in the negative here. You could plug in anything after, prior to negative 1, see that your graph would be in the negative there, right? So it's not magic. You could actually plug in, but the theorems and the rules make your life a lot easier if you can remember them, and you should remember them. Okay? You got it? You good? All right, say goodbye, everyone.
Bye.
Wake up, Julian! See, that's recorded for your parents, buddy.